Today's lesson is on applications of proportions. So we looked at proportions and now we're going to apply them. So these are going to be little mini word problems. They honestly will not be that bad. So go ahead and throw your date in your table of contents and we will get started. So here's our first example. Now when you take notes on this, you actually are going to want to write this out, and it's only 2 sentences. Well, it's only 1 sentence, just kidding. So it's not that much to write out. Go ahead and pause the video, write it out. The reason why is if you have all this work without the word problem, you're going to think that this lesson was on how to solve a proportion versus how to write a proportion from the word problem and then solve. So it's a different skill set. So go ahead and write that out. So here's our problem. If Sam... Alright, so someone just came in the room. I don't know what I was saying. I think I was about to read the problem. If Sam purchased 12 bottles of soda for $9.48, how much would he pay for only 5 bottles? Now I know that there's more than one way to approach this. You could find the unit rate and use that to get the answer, but we are working on how to set up a proportion from a problem like this. So all you do is you take the first information they give us. Sam purchased 12 bottles of soda for $9.48. So I'm just going to create a ratio out of that. 12 over 948. And I could have done 948 over 12 if I wanted. It honestly doesn't matter. What you want to do off on the side is think about what these labels are. The 12, it was 12 bottles. And the 948, that was our cost, so that's the dollar amount. So we're going to set up a proportion. We're going to set this equal to. Now they gave us one other piece of information that we're going to fit into this proportion. How much would he pay for only 5 bottles? So when you put that 5 bottles in, it's either going to go on the top or on the bottom, and the only thing you do is put it across from the one that's also bottles. So if you notice, we put our bottles on the top, and since it's 5 bottles, that's where the 5 goes. And then the thing we don't know is how much he would pay, so that cost is on the bottom. So we're working with simple proportions. You won't have to do any distributing on these. Cross multiply and solve. So we'll do 12 times x. So we have 12x equals 5 times 948 is 47.4. Go ahead and divide by 12, and we are going to get 3.95. Now because this is a word problem, I want to make sure that I label this 3.95. Is this a bottle amount or a dollar amount? And because, well, we can answer this 2 ways. It says how much would he pay, and we also put our unknown down here where the dollars are. So this is $3.95. All right, another example. The tax on a $400 bicycle is $32. How much would the tax be on a bike that costs $700? So there's that tax on a $400 bicycle is $32. So that's our first ratio. We can do 400 over 32. And then we just have to be careful about this. Is the $400 the cost of the bike, or is it the tax? And it says it's a $400 bicycle, so that's actually what the bike costs, and the tax is $32. We're going to set up a proportion with the other information they gave us. How much will the tax be on a bike that costs $700? So I just have to make sure to put that $700 bike across from the other bike. So the 700 goes up here. What we're looking for is the tax, so our unknown tax will be right here, across from the tax. Now I noticed that the variable is in the same spot as our last one. That's just coincidence. I was lining up my the units going across my proportion. So we cross multiply. 400 times x is 400x. 32 times 700 is 22,400. Let's go ahead and divide by 400 to solve. So when you divide by 400, you get 56. And then 56 what? What kind of label would this be? Well, we're finding the tax, and our tax is in dollars, so $56. Okay, here's our last one. It says a runner who is 180 centimeters tall casts a shadow 40 centimeters long. If a nearby tree casts a shadow 150 centimeters, how tall is the tree? So we have a runner, 180 centimeters, casts a shadow 40 centimeters long. So the runner, that's how tall the runner is. So in this case, I'm going to label this as height. That's the height of the runner. And it's the shadow that's 40 centimeters long. Set up the rest of our proportion. It says if a nearby tree casts a shadow of 150 centimeters, how tall is the tree? So that 150 centimeters is the shadow, so we want to put it across from our 40 down here where we're putting the shadow. So this 150 goes down here. The thing we don't know is how tall the tree is or the height of the tree, so that's going on top. So we cross multiply 40x equals, and you multiply the other side, you get 27,000. Divide both sides by 40. And we get 675. What kind of label would this be? Well, the shadows are all in, or the height is in centimeters. Basically everything's in centimeters, so 675 centimeters. So with these applications of proportions, we're looking at just a short little mini word problem. We set up a proportion, cross multiply, and solve.